live? We are live. Cool. My microphone, it's a little bit loose, but we'll fix it later. Alrighty. Welcome to another live session. So let's wait for some people to get here. And in the meantime, I'm gonna keep working on my asteroid. I'm doing an asteroid. Why? Well, because I'm doing a new project and I need some asteroids. So I'm combining a few noises to do this. Just playing around with stuff. Hey Adrian. Hello. Mush. That totally turns my asteroid the other way, which I don't want to. Alrighty. Nope. Cool. Too much. Santi, what's up? Bob, what's up, Bob? Quantum negative, hello. Volume is too low. I don't know, man. The microphone is the same. Let's see if I can raise it a little bit. Hello. Maybe I can get my microphone closer. Hello. Okay. All right, so maybe just turn your volume up a little bit. Hey Federico, what's up? Richards, what's up everyone? How are you guys doing? That's too much. Just trying to design some asteroids. Oh, that looks cool. That's like an erosion effect. But that's not what I need right now. All right. So I'm gonna stop with my asteroid and we're gonna start talking about today's topics. I'm gonna save that. And let's close Houdini. Let's close Blender. Yeah, I use Blender sometimes. Well, to get models. Let me make my interface bigger, you guys. Hey Grant, what's up Grant? What's up dude? Alrighty, let's restore Houdini. Yes, I do want to save that. And Houdini crashed. I don't know why it's doing that lately. Alright, so how's everyone doing? A lot of news from GTC. You guys saw the news? Redshift, Redshift just released a video about what they've been up to and the plans they have. But I guess the big ones is the Arnold announced the GPU version, which they said it will be ready when it's ready. So it will be out when it's ready, which means who knows? Who the hell knows when they're gonna release it? They've been working on that thing for a while. It's been a while, and it's not done. She's weird. The Arnold guys are pretty good at what they do, and also. RenderMan announced their, well, they didn't announce it, but they hinted about the what is it? XPU, right? Yeah, Solid Angle, it's gonna keep updating all the plugins. And Houdini is a huge market for Arnold, I'm pretty sure. So They're not gonna uh, drop Houdini or any other application for that matter. Alright guys, so let's talk today. Let me switch my screen. So today we're gonna talk about attributes. And attributes are I think the most important thing in Houdini. Let me go back to my big camera and talk about this. So attributes in Houdini, I think, is one of the most important things there are in Houdini. Basically, attributes is how Houdini actually works. There's all this interface with nodes and windows and stuff, and shaders and Vex code and all that stuff. But all that is just managing attributes. And if you understand that, you're just managing data, adding attributes, then you're gonna be really comfortable in Houdini, and you're gonna understand a lot of the stuff that happens in Houdini. So I think it's really, 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 really important that you understand attributes, because in Houdini everything is an attribute. Everything is an attribute. So let's see some examples. I'm gonna start with a few examples, and if you guys have questions, please let me know, and we can explain things. But let's start with geometry, of course, and let's put a sphere, a simple sphere. Okay, let me make this polygon sphere and show the. If you guys never use the geometry spreadsheet, which is by default here in the default layout, you should use it more than you think, because this is all the information that it's always happening in Houdini. All right, so I always have this here at the bottom because it is really useful. And this node here in the network view represents data, right? Represents data that it's showing us the result as a sphere, right? The sphere contains points, in this case are called points, and they contain vertices, they contain faces, etc., or primitives. But all that is just attributes. Okay, so this radius is an attribute, center is an attribute, uniform scale is an attribute. All this information is attributes, and we can see it here. If we don't see this viewport, let me switch that off. If we man, I'm not showing you what I'm doing. All right, let's start again. So all this stuff, as I said, is data, right? This is just a sphere represented as data. I mean, the data is represented here as a 3D geometry. Okay, so the sphere has vertices, faces, points, etc. But all that stuff is just basically data. This is basically the visual way to represent that data. This radius attribute is data. It's an attribute. Radius is an attribute. Center is an attribute. Uniform scale is an attribute. All that stuff are just attributes, right? So if you haven't used this geometry spreadsheet that it's here by default with the default Houdini layout, this you should use more than you think. And this is basically what is happening behind the scene, let's say, right? So this node is basically just a representation of a function, let's say, or this is like a thing that generates something. It has data, comes with data that generates this object in this case, right? There's different ways to see this data. The first one is this geometry spreadsheet, which is really useful. And in the top left here, you can see there's 4 buttons here. The first one over there, let me see if I can zoom in. Oh, cool, I can zoom in. Awesome. So here, this first button will show you attributes that are on the point. So the attributes can be embedded in points, vertices, faces, or primitives. Houdini calls them primitives. And in details, which basically details is, I think about it, it's on the whole geometry. It's like a global attribute, not pair vertices. So in this first, what is this node? What is the mode? Well, in the points mode here, you will store attributes on the points, or you have point attributes. This is for vertices. You can see vertices right now only has the point number, which is represented by. So this is the vertice, and this is the point. I think I'm too zoomed in, maybe. Let's zoom in a little bit less. And in the primitives, you can see we have no attributes right now. In details, you can see we have a column for detail, but there's nothing there. Here in this, if we enable this guy again, let me zoom in a little bit less again. And here in the view, you can see here is attributes that are available right now to points. There's a group attribute, map offset, and P. We don't see these two here for some reason. I don't even know what group attributes is. I never used that one, but the P is the position of the points, and so that's the 3D position on the world. So we have that here represented in these columns, and here in the far left, it's the point number. So point 0 is at these coordinates in 3D space, all right? X, Y, and Z. Number 1 is at these coordinates, and 2 is at these coordinates, all right? So that's how you view attributes. We will create some attributes and we will modify some attributes, but I want you to understand that everything in Houdini is just basically handling data that comes from attributes. So let's zoom out of this thingy. Hopefully you guys were able to see this thingy. You can edit the attributes here. That is not the way you edit attributes, Bob. We'll see how to edit attributes. You can't edit here because that is something that you shouldn't do, or I never done. This thing gets weird. It gets locked. So that's not the way to edit the attributes, really. So we will see how to actually handle the attributes. So there's different ways you can handle the attributes. Oh, and the other way, the other place you can see the attributes is middle clicking here on the node itself, or pressing this I, which is basically information for this. And you can see right now we just have one attribute here, which is the point attribute. All right. Yeah, point attribute. You can see that it's called point attribute, and it's P. And it's of type 3 floats. Let me zoom in again with this, because this is important information. So you can see it's a point attribute. The attribute name is P, capital P. It's really important that it's capital P. Then it's the type of this, it's 3 floats. And I don't really know what this pos is. I think it's just saying that it's position. I don't really know what this part is. But this is the name of the attribute, or the type of the attribute. The name, the type of the attribute here. I think this is maybe we can call this the class of attribute, or the parent attribute, or the storage place. And then this is the type. It has 3 floats, which is just like this, 1, 2, 3 floats. And that's what we have right now. Let me zoom out. All right, so Richard said, no, objects don't have normal attributes per se. You can see they do have, if we enable this node here, this button here, You can see the point normals there. They are there by default, but they are not like set specifically. So if you actually want to have normals in your attribute, you have to create the normals with the normals node. You can create a normal node, and then you just basically is the same thing, but now you have the normals attribute. Okay. So they don't come with the normals attribute, but they have it for display. That's what happens there. So that's the two ways we can see attributes. We can go to the spreadsheet. Some people like to see it here, see the spreadsheet here by right-clicking. I personally don't like that because why? It's here on the panel, or if you like that way, it's alright. But I don't really like that way. So that's one way, and the other way is middle clicking, which is very useful because you see the attributes here really quickly, but you don't see the values of the attributes, right? Let's see if there is questions. All right. Hey Orlando, what's up? So that's attributes. So now when you create another node, let's say we're going to transform this sphere. When you create a transform, let's hide the normals, and you add, let's say, 1 to the translate y. What you're doing there, let me show the floor so we know that it's moving. So what you're doing there is just for every point in the sphere, you're adding 1 to the position y. So let's see, can I have something to draw on? I don't even know if I have something for drawing. Let's see if that works. So let's go to the spreadsheet and let's see for 0.0, I think these numbers are big enough for you guys to see without me zooming in. You can see in y it's 1, but if we go before this node, if we click here, you can see this at this step here when the sphere is just created, this value is just 0. So when we go to the transform and add 1 to the position y, it's basically 1. I know it sounds stupid maybe to explain that. I added 1 and then now it's 1. But this is exactly what's happening in Houdini. I want you to understand that when you create this node and you start translating this guy, you can even see these values change as I move this. You are in fact just modifying the data that is driving that visualization here. You can see the sphere came up here because I moved it here. Why do I want you to understand this? Because everything in Houdini, it's a freaking attribute. It is really important. It is so important to understand this. And you can see even some people don't do this, and I didn't do this for a while, but the transform can actually transform any kind of attribute. By default, it's basically modifying the position and the scale, rotate, etc. But you can see here there's an attribute field here, and if we add normals to this guy, we can use the normal node to add normals. We can add it. Let's add it to the points. You can see them there, and let me make those a little bit bigger so we can see them clearer. Normals. Just like to make this one. You can see now if I just use this transform as it is by default, the normals follow along, right? But what if I type here or select the normal attribute, just delete that asterisk, And now it's not going to modify the points, actually. It's just going to modify the normals. And look at this. If I modify this, whoa, it's not working. Why is it not working? Let's see. You can see now if I scale the normals, it's scaling the normals. Look at that. So I've been using this for effects now, just trying to tweak the normals sometimes. If I need to modify them, I can use this really quickly. I think this guy, it's recomputing, and it's I just deactivated the preserve length because that was making it not be bigger like I wanted. So now you can see that instead of modifying the point attributes, or the point attribute for each point, the position attribute, sorry, I'm actually modifying the normal attribute. If we go to the spreadsheet, now we have two attributes here. We have the normal, which is these three columns here, and it's the position, which each one has N, Y, and Z attributes. That's what these three floats mean, which has three values that have decimals, right? All right. So far so good, right? This is simple stuff. So just so we know that this is cool, if we go to the advanced section of Houdini, like let's create a Bex thingy, attribute wrangle, and actually the attribute wrangle is telling you I'm gonna wrangle attributes, which basically means I'm gonna handle attributes. And in this case, it says what you want me to run over: points, primitives, vertices, or detail, which is exactly the different types of attributes we can have. Numbers is basically just running a number of times. So there's no attributes for numbers. So by default, it's points. But again, if we do the same thing, let's say to the attribute position, which attribute position you access it with that ampersand. I mean, no, that that's the add symbol. It's called add symbol. Let me make this larger. So that add means attribute. So just think of attribute. So let's say if we go to the points and we add 1 to the current position, let's say position Y, because we did that. We are going to add 1 to that. Let's say we are going to add the current PY. Let's add 1. So this is, let's say, the most advanced way to handle attributes in Houdini, because everybody's doing Bex these days and all that stuff. But basically, all that it's happening here is I'm gonna take the position in Y, which I know is an attribute. I already saw it in the spreadsheet, on the geometry spreadsheet. I know what's happening. So I'm gonna take that attribute. I'm gonna add 1. It's basically I'm doing exactly the same thing that I do with a transform, right? So let's zoom out and see the result of this. And when I press enter, look at that. It did the same exact thing. So let's create a transform actually. Let's put a transform here and put 1 here. So if I see this and this, that's exactly the same thing. We are modifying an attribute just one way or another. All right, this is just referencing the attribute directly in code, and I'm adding 1 to it. And here is basically a node specifically for that. It adds 1 to the position, or adds to the current position. So why is all this stuff important? Because if we now decide, let's say I'm gonna decide to add a material. A material is a shader. It's something that it's not an attribute, right? Well, it is. if you see here, if I just added a material node here, and if we go to the geometry spreadsheet, they said, yeah, you can see it's not an attribute. I'm telling you it's not. Well, if you see here in the right, and my Houdini is a little bit cut, right? Let me handle that. All right. All right. So if you can see here in the right, it says attributes, and it's telling you primitive attributes. Oh, it's doing it on primitives. So now you go to the primitives section here, and you should have an attribute. Well, it's not there. Well, we haven't assigned anything. So let's create a shader, a principal shader. And let's call this glass because, or fire, water, whatever. We would like to create water. Let's assign that material here, water. Now look at that thingy. Now it's populated and it says, oh, I have an attribute that is called shop material. And why does it have that name? If we even middle click here, you can see the primitive attribute here is now there. Well, this attribute, it's named like that because it will be picked up by Mantra when you render it, or any other renderer for that matter. We'll say, okay, geometry, are you ready for rendering? Yes, I am. Okay, so give me your attributes. All right, here's my position. Here's my normal. And do you have a shader? For sure. Here's my shader. And it gives Mantra this name exactly, and it says, all right, I see you have that material there. Where do you want me to apply it? Well, apply it to all these primitives here. You can see every primitive has the material applied. It's not like applied to everything. It's each primitive has the material applied. And why? Well, because if we create another, let me just copy this one. Well, I did not want it to do that. Let's copy this one and let's call this bricks, whatever. That means that if each primitive it gets assigned the shader, means, okay, I don't want to do that, means that here I can click this button here to select what I want to assign this shader to. So now I can select those primitives up here, which I am with this thingy. I don't want to select the connected ones. Go away. I just want to select these ones. Press enter. And now you can see I assigned the shader to those primitives. If we go again to the geometry spreadsheet, you can see a few of them don't have a material because there's no material assigned. If we go to here and let's make this water blue, of course, and make these bricks like an orangey color. Now let's say you can see now all the polygons that I selected here are just having that water material. Now let's select everything else and let's assign to those the other material here. Let's assign a new tab here, make a new tab with this thingy. Select those faces which are already selected, but it doesn't let me. Okay, let's see. I can select all this stuff, enter. Now I'm gonna assign that material here, which is the bricks one, right? Did I? Oh man, I did something wrong here. What? Oh, I did another shader. Sorry for that. Let me copy this selection to here. I don't know why I created a new material there. There we go. So now these faces, we can see it visually here, of course. You have these faces have that, and these other faces have that. And if we go to the spreadsheet, we can see that here, this is brick, this is water, this is And if you see, let's see, phase 0 is bricks and 1 is water, we can see that here. We can show the phase numbers here or the primitive numbers here with this button. And you can see here is 1, it's water. And where is number 0? Here, it's brick, right? Let's see if there's any questions. Can you see groups there? Yeah, you can totally see groups here. Let's see if I create the groups. You can even create these guys as groups, which I do most of the time. I just do that. I just create groups with the selection. Let's do that. Let's select all those faces there and create a group. Let's call this water group. And let's go and select everything else. Let me see. Create another group and call this bricks. Bricks group. Just so I know what I'm doing here. So now I have 2 groups here. And if you want to see your groups here in the viewport, you can even select by groups here with the, just press S to select tool, or just click this guy. And if you click this little thingy here, or go here, you can see geometry groups. Select that and you can see the geometry groups are here. And they are named exactly as you have them. You're going to select water, you can select the bricks. As I can see, I selected a few faces that are overlapping on the groups, but doesn't matter. So yeah, you can see your groups here. You can even see them like with a little kind of a shade of color there if you want. You can totally select groups here. You can view groups. You can view any attribute here. You can even, let's say, if we go all the way down here, you can see we have 2 colors. I mean the 2 shaders. We can actually go to attributes and show that shaders here and select by shader here. This is so cool that you can just select by shader and do whatever you want. Any attribute you have in the geometry, you can select by or view it here in the viewport. That's why I'm telling you, you need to master attributes. You need to understand attributes because attributes are the key to Houdini. The spreadsheet doesn't show groups because oh yeah, sorry, yeah, it does show them as a binary attribute here. So you can you can sort these columns. If you click on the column, it will sort them. So let's say if I want the ones that are on bricks group 1, you can sort them here. But it's not really useful for selecting. Like you can actually select all these guys here. It's not possible here. So it's only for information here. It's just for you viewing this data. All right. So again, if you want to modify any attribute, like Bob was saying, I wish that they made this editable. I kind of, I don't know. I'm not sure if I wanted to do that. But you can edit any attribute just by using Vex or just mod or using the nodes that are built for that. So basically, the nodes help you handle your data, wrangle it, like the attribute wrangle does. All right. So far we've seen position attributes, normal attributes. You can modify attributes with Vex or with the transform, which is for that. We can create group attributes. We can create material attributes, and we can select by those stuff and all that stuff. So is there any questions so far? Because we are going to continue to more stuff, which makes this cool. Let's I'm just gonna create it by hand, by shelf, because I like that. Let me assemble these nodes like that. All right, no questions. Okay, so let's continue. Now I want to make this ball. Let's call this ball. I want to make what everyone wants to make. I want to destroy it, right? So I want it to crash on the floor and then it's gonna destroy. So I'm gonna create a new geometry and I'm gonna call this floor. So now I'm gonna create a collision ground plane, better ground plane. And yes, I do use the shelves. Please use the shelves. Please use the shelves. Don't think you're just a freaking smarty pants. Just use the shelves. Smarty pants. All right, so that when I click the very useful shelf tool, it creates a ground plane, which creates this object, which just this object is just a visual representation of some data. All right, so we're gonna see that and why. So I'm gonna rename this to floor just so I know what that is. So it creates this AutoDOP network, which sets everything up for us not to worry about creating stuff manually, because who wants to spend time on that? All right, so inside the AutoDOP, which is the dynamics operators in Houdini, which you can see by the really fancy icon, or you can see it better here. Woo! Boxes. It will calculate. If you just see this from the outside, dynamics is like it makes cool shit, right? But it's not. Basically, it does just modifies attributes again. It's just handling attributes, and we're gonna see how. But just let me see. Bob has a question. If you want to change the y of 0 points, the same value. There is a lot of double clicking on them and changing in spreadsheet. Well, it depends. If you want to have several attributes, let's say you just want to modify all these points to one. Get away. I want to select points. Let's go here. Select, hide everything else. Say if you want to modify all those attributes to a position in 0, use the edit. Scale it in 0. And why is it not modifying the points? Now that's weird. There we go. It didn't refresh for some reason. So if you want to do that, you can use something like an edit sub to do that. Most of the time you are going to know which points you want to do this to. So most of the time you say I'm going to do it for 1 to 10 from points 1 to 10, and you will do that to those points, or points 20 to 30. I don't even know if I have that much points, but it does it for those points now. Or if I want to move them up a little bit more or down or whatever, you can do this with different things. The other way you'll manage points or groups of points is with a group. Put those points in a group, modify that group with a transform node. For example, let's say if I want to modify all the points on the water group, which I already have here, right? I already have the water group there, and I want to flatten those points. I can use a transform, and in the transform I can select that group here, the water, and why is this thing? Oh, I'm not doing anything yet, so let's scale that to 0. And now I scale those points down to 0, right? Now it's important to know where my pivot is. My pivot right now it's at 0, so it's scaling down here. But if I want to do anything else with those points, I can flatten those points up here, but by keeping track of those points in a group attribute, right? And you can see all a group is just getting the points, or in this case, the primitive numbers. Each primitive has a number, so the group says the members of this group are those guys. You can add to this list. I want to add 20. I'm going to add 20 is already there, 21. Or I want to remove these 3 guys from the group. You can do that totally. It's right. There's nothing wrong there. So now let's go to simulation, which seems to be a really difficult part of Houdini, which is not. It's not. It's a heavy thing to calculate, but it's not hard to understand. So, and when we go to simulation, and we right now we just have this floor, so nothing is calculated basically. So now let's make this ball a rigid object, and we can do it just with using the rigid bodies, and let's just create a rigid body object here. So now you can see the color is gone, and we will talk about why in a second, but now the color is gone, and if I press play, the thing drops and it moves on the floor as you expect with the simulation. Let's make this real time. Okay, let me drink some water. All right, so what's happening here? A few things happen, all right? And if we go back to the ball, actually, first you can see that the very handy shelf tool created everything we needed here. Let's unlock this guy. I don't know why that's locked. So it created a few things, basically these 3 nodes. So the first thing it's creating is a rest attribute. And the rest attribute, it's the initial position of the object before simulation. Basically, you can understand it like that. If we go to the geometry spreadsheet, we will have a point. In the points, we'll have a rest attribute here. Okay. If we see here in view, you can see now we're getting more attributes here, and we can see. Let's say I want to hide all attributes and just see the rest attribute, and we can clean up the spreadsheet so we just concentrate on the attribute we want to see at that moment, all right? Let's show all attributes. It's cool. Map object don't see that, and all right. So now you can see we have that rest attribute, and the rest attribute it's useful because it helps the textures. How can I explain this? Basically, it helps the textures stick to the geometry. If you don't have a rest attribute, sometimes, and then you simulate it, the texture will be like swimming on the object. It wouldn't stick to it. And then it creates this assemble node, which is an HDA actually, which creates some more attributes. You can see, but now it just you can see our attributes are actually gone because this creates a special kind of geometry, which is called packed geometry. And then it creates this top import, which imports more attributes. You can see now we have like active, animated, bounce, bullet, length, bullet. We have actually a lot of attributes here. It's a bunch of attributes. And you can see there's actually rest as well. It's there. So let's go. So all this happens in the geometry part of this, and then let's go to the dynamics part of this, and then we have this ball, which is the ball that we imported, make a rigid object, right? In this side is the ground plane. Actually, we don't even need those nodes there because this node is just a mesh. If you have another static object, you plug it here. But when you just have a ground plane, you don't need this. You don't even need this static solver. You can see it will work even without that because Houdini is just smart enough and knows that object's gonna be static. don't worry about it, etc. We don't need this node as well. So it's gonna simplify things here. And you can see we have two objects here, the ground plane, which is a static object, and we have a ball, which is the, in this case, the non-static object or dynamic object. And what's happening here in dynamics is that we have more attributes, which are now attributes that will, that the solver here, like I was explaining before, all right, Adrian, don't worry about it, man. Now, before I was saying that mantra is taking the attributes the objects have and then renders those. But now here in dynamics, in this case, the rigid body solver is telling the ball in this case, do you have a velocity? Yes, I want to go that direction. All right, let's go in that direction, and I'm gonna make sure that each frame your velocity it's constant, or it decreases, or gravity here below, it's telling me that it wants to pull you down. So I'm gonna pull you down as well, all right? Because gravity has this attribute of force that it's pulling you down. So I'm gonna multiply or add your velocity by that attribute, so you're gonna be falling, right? So that's what the solver is doing in a very, very, very basic way. And all that stuff gets summed or multiplied or divided or whatever, that data, and then it gets output here. And you can go again to the geometry spreadsheet and see this is a different spreadsheet, but it's very similar at the same time. You can see a lot of stuff here, like relationships, how objects relate to each other. I love the collide. Are the collide? I think they changed this. Collision. Doesn't matter. We're talking about attributes right now. Relationships. Doesn't matter. Okay, but if we go here to the ball, oh, there's the effector matrix. That's what I was looking for. Here it says that can we scale this down? Yeah. There's two objects. There's a ground plane and there's a ball, and it says how they are affected. Like what's their collision relationship? The ground plane collides with nothing because the ground plane it's just a static object, and the ball collides with the ground plane. You can see ground plane affects ball, and here says ball affects itself, so it also affects it's affected by itself. So these are attributes that dynamics knows to know which one it's going to bounce, etc. If we go to the geometry section here, now you can see the attributes we had before. You can see there's position. There's a few other attributes here which makes this object dynamic and have attributes that Houdini needs to know. But if I go forward one frame, you can see the position starts to change, and we know the object is falling. So the position why it's gonna start changing, you can see it's going down, it's going down, it's going down, it's going down. And that's basically what's happening here. The position it's being subtracted by this amount multiplied by the amount of the gravity here. All right. So the solver in this more basic way is just taking those two attributes and says, all right, so you will have this attribute here. You don't have any velocity now. Well, gravity is telling me to pull you down. So to your current position, I'm gonna multiply this guy each frame by this guy each frame, and I'm gonna subtract that to your position. And then when you collide with ground plane's telling me to not let you pass this point, so I'm gonna do that. And then it just populates the position attributes of the sphere again. So in a very basic way, that's what's happening. And then let me see if there's any questions before I continue. Okay, so I'll answer your question in a second, Bob. All right. So then these attributes get calculated, and then we have this output here, which has all that stuff. You can see now there's a bunch of attributes here: density, deforming, active. But in this case, the one that is really important is the P, or the position, because we are not messing about with all this data right now. We are using that data to calculate the position, the final position, but at the end of the day, the only attribute that matters back in geometry is the position and the rotation of it, right? So let's go back to the ball, and now you can see the ball, it's moved over here. This is the ball before simulation, and then this is the ball after those attributes are being changed to this place. And the one that imports that data back is this guy, the DOP import node. It's saying what DOP network are we talking about? Is this guy. And then which object you want me to import? This guy. And you can see it's fetching geometry from DOP. It's pulling the geometry and everything from there. We could just import the data and apply it, but why? It depends if you want to do that, but you can see it even says here, transform geometry with position data, yes or no. Transform geometry with geometry data, which right now we don't have because it's not being deformed. Percept world space, etc. Right? It says that add a DOP object, a path attribute, which would be here, DOP object, which it will be just the name of the DOP object that we had, I think. As it's the DOP network, and then the name of the path, etc. So, but if you are observant, or if you are being paying attention, you can see that why do we only have one attribute here? We just got 1 point now? What the hell happened? I can see my sphere has all those points there, or supposed to have all those points there. Why am I just seeing 1 point here? Well, if you go here at this level before the simulation, you can see we have all these points exactly. We have exactly 42 points. And in scene view, if we go here, in scene view, in DOP here, if we middle click here, we have 1 point. What the hell happened? Well, we have this thing called packed geometry right now, and that is being created by this guy. You can see here is this create packed geometry, and packed geometry basically says take an object that it's continuous, let's say geometry that is connected, and makes one piece out of that, represented by 1 point. And that is a very efficient way that the guys at Side Effects came up with to simulate geometry really quick. So when this geometry comes back from simulation, now it's packed geometry. We can just convert this. So packed geometry, since it's just 1 point, it doesn't show us our primitive attribute that has the shaders that we added before. Remember, we added these attributes, but they are not lost. They are in the geometry. Maybe we can see them here. I'm not sure. I don't see them, but when there's a node to unpack this, basically it's just called that unpack. When we unpack this geometry, you can see our attributes come back. And you can even just, you can see here is our attribute, the shop material pad here. And if we play this will still be animated because we are still extracting the data from there. But now we have this geometry, all its points are back to normal, let's say. It's just important to know that that process happens for simulation, which is faster for just for rigid bodies. You can even tell which attributes you wanna import here. I don't think you can see that because it's out of frame. I can move it a little bit. You can see here you can import or transfer other attributes that come from simulation if you want to. But if you don't, I think the ones that you should transfer most of the time are the velocity, because if you want to render this with velocity, it would need that for motion blur. All right, are there any questions at the moment? And did I stress enough the importance of attributes? You can also transfer attributes. I can show you. Let's just do it with Roberto, because I don't want to create something from scratch. Let's just create a Roberto. Let's say that you've been working with this model. Let's do like a real life scenario. Where's the mosquito doing here? Let's say that this guy, it's you have this model, and you're gonna do the let's do something crazy actually. Let's say that I want to fracture this object. All right, I want to put it up. Let me delete. This guy has some attributes, so I'm gonna delete those attributes first. So let's simulate a workflow or something. Let's delete. It does have normals. I'm gonna delete those. I'm gonna delete the UVs. So let's say that you are working in a studio, and you know we need to do this Roberto dropping on the ground, and it's gonna fracture when it touches the ground or whatever. Can you please start with that, and while the modeler finishes the UVs, and you're like, all right, if I'm in Houdini, yes, sure, I can do that because it's Houdini. If you're in another application, you're gonna say, oh wait, no, everything needs to be done before I even touch the model for simulation, because if not, I'm gonna be screwed. I'm gonna have to do it from scratch, etc. Well, you don't in Houdini. Houdini, you can say, yeah, you go ahead, finish the UVs, and I'm gonna start with this model that doesn't have UVs. And when you have the UVs, you can send them to me, and I will be happy. So how do you do that? Okay, so I'm gonna create another .NET here to keep it separately. .NET Roberto. Missing a node there. Just gonna make this the active one, so when I'm going inside, when I create the object, it's gonna create it with this one. So I'm gonna fracture this object really quickly. I never know where this thing is. Shatter. I'm gonna shatter Roberto. So it's broken. I'm gonna add more pieces because 10 it's lame. And let's see the pieces because it looks really cool. Visualize pieces. So we have that, and you can see we are modifying the geometry. And we are working. Maybe we work 2 days with this, and we are gonna be able to conserve all the work without losing anything. All right, so now we have this guy that it's fractured. It's still not, let's do 30. Not enough chunks. Uh, let's create it, let's make it a RBD object. Let's go with a fracture object because it is a fracture object. Fracture object. We always want to use packed object in, unless you know what you're doing, just always choose packed object. And it's gonna create some stuff here in geometry. It will create as well some attributes for us. So now we can create a ground plane here. Just merge it here, it would work. We don't have gravity. Let's put gravity force. And now it should be dropping and fracturing. And let's say you show this to the director and says, you know what, it doesn't have enough pieces. Can you please modify the amount of pieces? Yeah, sure. It's Houdini. I can do it, man. I'm gonna make it look like it's hard, but it's not. But I don't want to tell you that it's so easy because. So now we have more chunks, and I should have like about 50 chunks here. Right? I didn't make sure it was 50, but it should. 82. I have 82 pieces. Okay. So now we added more pieces and stuff, and the director says, or your supervisor says, yeah, the fracturing looks really cool, man. You know what? Let's have it cluster a little bit. All right. I don't want all those pieces just to look so unnatural, so rookie. All right. So let's just cluster a few of the pieces. Yeah. That looks better. Clustering a few pieces looks way better. So now, you know what? The guy from, yeah, you can add a second fracture if you want. Just add it here before doing that. You can fracture it as much as you want. Yes, you can do that, Sandy. I'm not gonna do that right now, but yes, you can do that. You can do that even with dynamic fracturing. But let's keep up with our example. All right, the guy finished the UVs. Here's your model. You import the model, and then it's this one. It has textures, it has UVs and everything, and you're like, all right. So what do I do now? I have this guy that it's already simulated and whatever. Well, this is Houdini. You are not going to transfer. You cannot transfer. You can transfer the attributes to the object, but you're not gonna do it here because here the object it's already fractured, it's already animated and stuff. So what you do in Houdini is you go up here. You do it before all this stuff. Even before you even transform this, when it's at the same place as this guy, you can select this guy, attribute, transfer. So you put an attribute transfer, plug this guy in the second input, and say, what do you want to transfer? Well, I want to transfer in the vertices. I know I have UVs, so let me transfer the UVs. Let me transfer, even if this guy's already shaded, let me transfer the shader. And now here, before I didn't have UVs because I deleted those. Now I have the UVs. And even if this guy is not sometimes if it's not even the same topology, it would work. Sometimes it doesn't work, but there's ways to do that. But now you can see that if I go all the way down here to DOP import and press play, seems like it didn't work. Like, why it didn't work, dude? You said it was going to work. Well, remember these guys are packed, so we need to unpack them. Unpack them, and you can see now the fracture has the texture, the UVs, everything is working. And let's kill the visualized pieces so we don't have that color overlaid. So you can see that worked perfectly, and that's the power of attributes. That is the power of attributes, guys. So hopefully this is clear and of why this is really important. So Sandy was saying that can you fracture it again? Yes, you can fracture again this guy however many times you want. It doesn't matter. Let's say let's do another Voronoi fracture here. Plug this geometry. We need some points. Let's scatter some more. We can even basically repeat this process here. Scatter some more points to these guys. Scatter more points on those guys. Let's say 50 again with another seed. Then plug this guy there. And now that guy is fractured again. You can see it's fractured again. We plug that there. And let's go to the simulation. And it works. You can fracture it as much times as you need. Okay. If you wanted to fracture another time when it bounces off the floor, there's several ways you can do it. We're not gonna cover it right now, but basically you can do it with the fracture. Fracture solver, is it? No. Dynamic fracture. How's that thing called? I always forget about that. Fracture thingy here. You can do this guy. You can put this fracture configuration object, and you can give it the amount of fractures you want here. It's gonna fracture by. Let's put the guy over here. So it's gonna be slower because it's calculating on the fly with the collisions, with the impact points. It calculates some radiuses and collides with those, the collision of those radius, and fractures based on those radius. So it's not as fast, and since we had like a bunch of geometry here, I think it's taking a little bit of time. But that's how you can do that thingy. So, all right, let's go to questions, and hopefully this was clear, because attributes are really important. And if you didn't understand this thing, please watch it again, ask questions on the forums, and we can discuss the whatever you didn't understand. So if you don't know where the forums are, you can see this thing is taking a lot of time. Okay, let's see. Let's try to, let me see if I can cancel this because it's taking too long. Maybe Houdini crashed, I don't know. So if you don't know what forums I'm talking about, if you go to mixtrn.com, there's a community link here. Please go register there. If you want to buy our training, which is more advanced than the tutorials we have in more in depth, the tutorials we have in YouTube, we have these paid courses here. And if you go to the community section here, there is a really nice forum. You can see here there's a lot of questions that people ask, and we help them there. So please go to MixTRN. We just released this guy here, this latest course, which is rendering and compositing for the LAMP project. You can see I have access to it right here. All those lessons. We use all this software, Houdini, Redshift, Fusion, Painter, and we do the rendering mantra as well. So if you want to get more in depth with these courses, go and buy some of the courses we have there. And this guy, let me see if I just disable these fractures because it's taking a bunch of time, and we can fracture it. What's happening? This shouldn't be fracture, right? I'm not sure why this is showing us fracture already. Shouldn't. Nah. Okay, now it's a little too heavy. I don't really know. Why is that thing showing us fracture? Okay, this thing it's not. There we go. Now let's see if that works. Should work. There we go. It's working now. So now you can see it's fracturing on the fly. It's wherever it collides with, it fractures there. Now it just fracture once, and then it hits again. It will fracture again. So that's one way you can do that. That fracturing. Stephen Chuk, I am planning to make a bundle for the for all the lamp project videos. So if you want to wait for that, I'm not sure when I'm gonna make that. Maybe today or tomorrow. But yeah, I want to make a bundle for that. So you guys gonna get the three titles in one go. I can do that. All right. So Bob said he wanted to animate a sphere on an orbit. So let's create like a planet here. Let's call this sun, and of course it's gonna be a sphere. So that's the sun. Let's copy that one and make it Earth. So this one's gonna be smaller. I'm not sure how many times the Earth is smaller than the sun. So if we press space Y, we can see both objects. So if you want to make this orbit along this guy, you can use a really simple transform node. And the transform node, you can move the Earth. I'm just winging this. So let's see if you have the distance here exactly. You will do that exactly. So you want to rotate this in the y-axis, right? So if you rotate this in the y-axis, it's gonna rotate in its place. But if you move the pivot to here, let's say we can just subtract this same parameter, copy this parameter, paste it here as a relative reference, but subtract it. Now the pivot is here at the center. And now if we rotate on Y, it's gonna rotate around the sun, right? The other way you can do this is one way to do it. If you don't wanna do an expression or whatever, you can move Earth here, Earth. Then create another transform and say this is gonna be the orbit. And when you create a transform by default, the origin is gonna be at the center of the world. So just make sure the sun is the center of your galaxy in this case. So now if you animate the orbit object, it's gonna be animated around the sun. If you wanna do like an expression, just put $frame there and it's gonna be automatically rotating forever there. This way, this is a good way because if you want to move the Earth closer or far away from the sun, since that kind of does happen to Earth, it's not like it's not totally circular. So you could actually maybe make it here closer to the sun, maybe at this section, and it will be closer or whatever. I don't know. It's up to you. What I was modifying the wrong attribute actually. Uh, so yeah, you can animate it. Let's say that at the here it's gonna be at that distance when it goes. Let's say let's multiply this by 2 so it's faster. And here it's gonna be different. Let's say 7 because it starts closer, then gets away from the sun or whatever. I'm not being scientific here, but if you want to be, you can just get the right values or the right orbit of this. So now it's just gonna be like in a ellipse instead of a circle. So you can do whatever you want, but yeah, that's one way you can do it. If you don't want to animate that, you can just forget about it and just make all your planets, and that's once you have this guy, this Earth, you can just duplicate it and say this is gonna be Jupiter, I guess. And basically you just have a template now for planets. You can make this bigger, make the distance different, and it's already orbiting. Just change the orbit speed, maybe. I'm not sure how you call this, and it's gonna orbit differently. And there you go. You can make your planet as accurate as you want. Again, I'm not doing it accurate here, but you can do it. All right, there was another question here. Yeah, this tool that I have to add notes, I'm gonna release it soon. Soon. It has some bugs that I want to fix, and then I'm gonna release it. Once the surfaces are broken in pieces, one part is missing the shader or UVs. How you can select and apply quick UVs? Yeah, when you fracture some geometry, it doesn't have UVs, but you can add UVs really quickly. And most of the time, you don't need to have really accurate UVs on those things because it's just let me hide these guys. And let's fracture this guy. I should just be able to do shutter. And I'm not going to, that's just going to assemble these guys and explode them. Yeah, these guys inside don't have UVs or whatever, but you can add them here when you are at this. Again, you should do it before simulation. So here it's gonna be, there are gonna be two groups, the inside and the outside. You can see if I put a delete node here and I delete and the outside group, you can see it just leaves all the faces inside. If I delete invert this, I'm just deleting the inside group. So you can say let's there's an auto UV tools from the game development tools. You could use that to add UVs. It takes a little bit of time to calculate things, but I don't want it to do that. You could there's no group here. I'm gonna tell Luis about that. Why is there's no group selection here? That's a bug. You could use the split node. In the split node, it can give you. Nah, not the split. I don't like the split node. But anyway, you could use. I just use a delete sub. You could just use the delete. Put that into the UV. Into the auto UV tool. You can see now those guys have UVs. it's a mess, but you can change this here, make it different kinds of UVs. Maybe use another kind of UVs like the what is it that I've used, UV unwrap maybe. You can see now those pieces are unwrapped. That looks way better than any other thing that I just did. And just lay those out for UV layout. Cool. Now you can mix this with the other object that already has UVs. Let's attribute transfer. So we're gonna transfer only to the inside group. Oh, here, sorry. Only to the inside group, we're gonna transfer the UVs from this. Transfer the UVs. Now you have that, but the UVs are on top. So what the hell? Those UVs are weird. Those UVs are weird. Okay. So you could do another UV layout here. Again, it's up to you how you manage this. But yeah, you can give UVs separately for those guys. Then just add a quick shade to see if those guys got the UVs. But yeah, you can see now the inside parts have UVs. The UVs I just did are stupidly horrible, but that's how you could do those UVs. Yeah, and you're not affecting the other objects. You're just affecting the objects, the UVs on the out in the inside. But yeah, you can add UVs to them and then simulate after this. All right. Maybe is there an option in the Bornoi? I don't think there is an option here to add the UVs. It will be nice to have the UVs added here, but there's no option for that, I think. No. So basically, you just separate your insights and do it, handle them yourself, and that will give you the right thing. Alrighty. Actually, I think it will be even better just to delete the other thing here. Delete just the outside. No, delete the inside. So we have only outside and only have inside here, and just merge the two. Merge these two guys. Now we have that UVs, and then we can just do the UV layout here and have better UVs like that. That's a better way to do it, because I don't know why this guy was giving a messed up UVs. But yeah, you can do that, and let's see, this will be way cleaner. You can see, there we go. Way better UVs inside, but these guys, just make sure that you don't lose your connectivity thingy. But yeah, there's ways to handle this. Alrighty, so okay guys, so I hope you enjoyed this one. There's no other questions, right? Because we are going to finish right now. So if you have questions, tell me right now, because we are done. And hopefully this class will give you the tools to master your attributes. So remember that in Houdini, everything is an attribute, and all you're doing is just handling those attributes, right? UVs are attributes, color is an attribute, position is an attribute, everything is an attribute. All right. Thank you guys. I don't have an idea what I'm gonna talk about next week. I never planned these live sessions. I just wing it. So I will see you guys next week. Please join. And attributes are attributes. Yeah. I will see you guys next week. Thank you for being here. I really appreciate you guys being here with me, spending some time. And let's keep learning together, all right? I'll see you guys next week. Cheers. And I need to find that freaking button. I know where it is, but it's always far away. Bye.